My name is Drew Malone. I'm with Cloudera. I am the DevOps guy. I've been introduced as the DevOps guy every time I go and meet someone, so I should start putting that on the business card. So what we're here for today is Salt is not configuration management. It's so much more than that. Quick background on myself. Again, with Cloudera, I'm on the internal systems and tooling team in Cloudera. All the in-house applications, I help streamline them, take care of them, curate them. If you were here at last year's conference, you might have seen my talk on Salt Cloud, entitled Salt the Cloud and Make It Rain. I'm trying to keep up with the interesting taglines. And was fortunate enough to be here for the first SaltConf where I was able to sit for the exam. And got myself a single-digit cert number. So just to be sure, so you've got about 30 more seconds before you can walk out of here without hurting my feelings. This is the slide that's going to let you make that decision. If you're new here, new to Salt, and you're overwhelmed by the docs, we're here to help. If you're a veteran to Salt, you already know all the tricks, you're tired of them, you want to learn a few new things, hopefully you're still in the right place. If you're really just wondering why you're still here and you just feel an obligation to hang till the end of the conference, I promise it's going to be quick and I'm trying to make it entertaining, so it'll be worth your time. Stick with it. Brief outline of what we're going to be doing today. We'll go over a quick history, a story of you, a story of me, a story of how we got here. We'll then go over a quick crash course, an inventory, if you will, of the various components in Salt that you may or may not have heard of, with a little quick description. Having done that, we've got our box full of Lego pieces, and we'll show you what kind of capabilities you can deliver when you put them together in interesting ways. Once we're done with that, I'll show you all the things that I didn't have time to go over. I'll give you a little bit of homework. You can read up on them later on. And at the end, we can all congratulate each other for making it through another conference. So a story. Remember the first day on the job? A lot of machines, SSHing in, fat fingering config files, fixing misconfigured services. 3 of the machines work, 2 of them don't. Don't know why. It's not really working out. Let's try to automate a few things, because we're getting more machines. I have never once been told we need you to deliver fewer services. It's only more services. So we're starting to script a few things. We're starting to get consistent results. You might have a playbook. If you're really good, you might have a Git repo where the team shares those scripts. Once you get the feel for that, we move on. We start actually using config management now. We're getting comfortable with Salt. The team likes it. Management either doesn't know it, doesn't care, or you actually have buy-in. We've got automated deploys. It doesn't matter how many services we're delivering now because we've automated it all. Things are consistent. They're reliably up. Things are great. Congratulations. You've won. Y'all can retire now. You made it. Successfully using configuration management to manage your services, deliver business capabilities. So, someone in the audience, feel free to complete this sentence. What's the reward for good work? More good work. That's right. Y'all are so good. So, you're delivering all of these great capabilities. Y'all are really good at what you do. We need you to do more. We need you to put together these completely unrelated systems. We need them working together in harmony. We need them delivering new capabilities. We need you building not only more of these systems, but more complex systems than this one you just finished. Oh, and those are going to be a little more complex as well. Also, we're going to have them delivering capabilities in real time. We can't do batch processing. We're not going to be working with customer requests. We need this thing working up all the time, and it needs to be trivial to deploy something, even if it's not related to any other system. Great. I can't use a config management system to deliver all those things. I got to learn more tool sets. Now I got to go and find out what new tool sets are going to help me deliver those capabilities. As it turns out, you already have those tool sets if you're using Salt. Like I said, this is so much more than config management. we've got a whole set of components that you might not even know you have. You don't even have to install anything extra. So my intention here is to show you that they're not just interesting tools that you can look into out of curiosity. These are very powerful tools when assembled in interesting arrangements. You can deliver capabilities that, frankly, I have not seen any software, open or paid, deliver capabilities like this before. So the last point I want to make before we go on with the inventory. Again, Salt is not just configuration management. Salt is a parallel remote execution engine built on top of an event message bus, upon which you can build a configuration management capability. But you need to realize that event bus is the central nervous system into your data center. You can build so many more capabilities on top of this when you start to see what these components are able to do. So I'll give you about 5-10 seconds to read this. It turns out it's really difficult to make a good-looking yet organized list of components. A word cloud is confusing, and putting a grid in the table looks like a table with a grid, so it's an eyesore. So with a show of hands, can I get the people who are familiar, at least conversationally, with every item on this slide? Amazing. You guys are one of the lucky 10,000 today. Thank you for coming out. We're going to go over each one of these. So, Salt Reactor. Like I said, you have an event bus that you can use that is the central nervous system into your data center. What if you had some process that could monitor these things, that could look for an event on the bus, and when it sees an event on the bus, fire off some ability, run some script, fire some API call. This is what Reactor does for you. You write your salt states, you map them to events on the event bus. We'll get more into the application of this a little bit later. Salt Cloud lets you codify your footprint in the cloud. So you can write a simple YAML config file to describe what OS version, what flavor, what size instance, and you get to pick your cloud provider. Rackspace, DigitalOcean, EC2, you name it, they've written a driver for it. It's amazing the amount of work that's gone into Salt Cloud. It makes it trivial to deploy complex web systems up in any cloud of your choice, to include VMware and local hypervisors. Salt API is a favorite for especially something like continuous integration, CI/CD platforms. This is your programmatic access to everything Salt. With a proper Salt API setup, anything you can do on the command line, you can do with the API. And now remember, that's just a quick HTTP post call. So anything that you can write that can send some HTTP post to your Salt API system is now your entry point into orchestrating more complex workflows. The Salt Mine is a small, I don't want to call it a database, but it's a small storage of information provided by the minions handed over to the master. And you get to define, there's a handful of pre-built data that can be sent in from the minions, but you can also define any interesting facts about your minions and have them send it over to the master to be inside the Salt Mine. Once it's there, a simple query into the Salt Mine executed by any other minion in your system lets you get more information out of your deployment. Salt Orchestrate. Amazing. If you're familiar with state files, with SLS files, Salt runs, those are scoped to single machines. You can run complex installation and configurations on a single machine. Orchestrate lets you take those atomic work units and go one level higher, so that now the scope of work is no longer a single machine, but is every machine in your data center. To bring it to a point, as a trivial example, suppose that the database server needs to come alive and be ready before you're going to stand up the web server farm, before you're going to stand up your reverse proxy that's going to sit in front and handle all the traffic. Orchestrate is the capability that lets you define that order of operations. Anybody here ever get pushback because they don't want another minion in their data center? I understand. So this is your answer. So you don't want or can't have a minion on your system. No more agents. Fine. Let's use Salt SSH. Still surprisingly fast, even though it turns the transport layer from the 0MQ message bus over into SSH. You lose a few of the capabilities, but if you want configuration management and you have staunch upper human management that resists the installation of any more minions, this is your break and enter team. Salt Vert, the primordial phase of what Salt has become. I'm leaning on some of the Salt members to correct me if I'm wrong. I believe Salt Vert is the first iteration of Salt because Tom wanted something, a database-less way of controlling hypervisors. Everything out there was too complex. You just wanted a simple way to manage a local hypervisor. So what Salt Vert does is it turns your laptop into a data center. If you have a hypervisor, you can very easily spin up a bunch of VMs on there without having to know anything about your underlying mechanism. Engines are interesting. It's one of those things where when you first see it, you think, I'm not really sure what I would use that for. But when you find the use case for an engine, absolutely nothing else would do instead. This is a process that runs alongside your Salt master, or minion, I believe, and has access to everything Salt has access to as well. So if you want to write your own process that can attach to the event bus and do whatever you need to, monitor the events, send out metrics, catch API requests and execute some function as a result, anything you need to, you can very easily define all the configs and parameters in the same config setup as you do your master or minion. Very easy to get stood up. Beacons, the close relative of the engine, they're your boots on the ground. They are the ones that live out on the minions, and they also tie to the event bus, and you can have them, do anything. You can have them map an event on the event bus to some action, or if you're tired of the event bus, you can step out of that, and they are your exposure to the real world. As a quick example, you can use something like the iNotify beacon to monitor some config file that's very important to you. A beacon can fire off an event that says this file has been modified, and you can configure your Salt deployment to update that config file immediately. We'll get into that a little bit later in the how-to. Just in case those components are not enough for you, you can customize it. Salt is intensely hackable. It is very easy to get started. You can write your own custom modules, you write your own custom grains, you can implement your own pillars. It's incredible the things that you can do. If someone hasn't already written it, which is surprising, but if it's not already been implemented, you can write your own module. And the documentation is actually very good at helping you get started with that. So that's our quick inventory of the various components of Salt. So let's walk through a couple of use cases when we put them together in interesting ways. What I was just talking about, state enforcement. So take our beacons, combine it with reactors, and you get what I like to call anti-cowboy measures. Anybody have a resident cowboy on the team? Anybody have a couple of cowboys on the team? So here's how this works. We're going to minimize the impact of that cowboy. We have defined our config file. It doth look like this. We shall put the config file out on our systems. The cowboy comes along. I want to put my buddy in there. I've got access to the system. I'll just add him in there. That'd be great. Your beacon immediately fires off. Your iNotify beacon says, this file's changed. You need to do something. And so when you've configured it properly, what Salt will do, and this is immediately, you don't have to wait for your next high state. You don't get a notification telling you it's changed. This does it for you. You do nothing. It will immediately turn around and restore that config file, restarting the services if necessary. It's like the cowboy was never there. One of my favorites, Salt Cloud. So I understand the pre-conference training. All the VMs that we all logged into were all made with Salt Cloud. Very easy to define your provider, your profile, and get it set up. Again, the docs are very good at getting you started. Then it doesn't have to be a size of 1,000 or 100. You can have 5 guys getting together in the office after hours. And this is great because not only will it make VMs for you, you can specify follow-on automation to set up some development environment or set up some class environment with examples. Okay, so we'll get to something a little more interesting. This is a 3-tier web app deployed with Salt Cloud. If the text is not too thin or small, you can see what this looks like. This is a simple YAML file describing the UI, a little MongoDB server, and an Nginx to sit in front of it all in a reverse proxy. So we feed that to Salt Cloud, it rolls it out there, instant 3-tier web app. And the last one is, I don't have any pictures or photos or anything with this, is a story I was told when Salt was brought in just as a requirement. A large company was running a bake-off. They had to have some vendors come in, display some capabilities. They needed the capability to run some compute farm. It doesn't matter what it was. They needed to be able to run it in some cloud. And so bringing Salt into the conversation was an afterthought. And so what they did was they went over the requirements on a Friday, and over the weekend, what the one SaltStack employee managed to pull off over a slow weekend was build this small, simple, automated script that would query the costs in all of the available cloud providers, come up with what it would cost to run that compute farm in each cloud of their choice, automatically pick the one with the smallest cost, and then use Salt Cloud to deploy that farm into the cloud provider, set up the compute farm, and get to work. So push a button and you get the most cost-effective result. They wound up going with Salt in that case. Portable autoscaling. Did anybody take any of the pre-conference training? Was anyone there for the autoscaling, reactors, beacons, the whole thing? Excellent. This is effectively what that went over. So let's see what happens. So you have a website. It looks great. You've got a little reverse proxy because you're responsible. Users start to look at it. The user likes it. User posts it on Reddit, posts it on Slashdot, shows it to all his friends, and then they show up. Your website's very sad. Users are very sad too because they can't see their cats in a quick manner. They have to wait for 10 seconds for those cats. Your site's not popular. So what happens here is you have beacons. You have the load beacon. It monitors the load on all of your servers. You set your thresholds. The beacon says, these guys are under way too high of a load. We need to do something. The beacon fires off a message up to the Salt master, who then says, we need a little bit more horsepower here. Please make me more UI servers and put them in the app farm. Fire up the Salt Cloud, add more servers into your app farm, more horsepower, faster cats, happier users, better website. Again, completely hands-free. So some people will say, well, just put it in EC2, just put it in AWS. They've got autoscaling for free, which, okay, that's cool. DigitalOcean doesn't have autoscaling. Rackspace, yeah, they have autoscaling, but it works different. Linode, I'm sure they have autoscaling. It also works different. When you create your own capabilities, you don't care where your services live. You can put them in anywhere you want. Avoid vendor lock-in. Do it yourself. Salt makes it easy. So this one is straight from my day-to-day. Salt API plus Reactor, never update your production configs again. Is anybody here familiar with Remon, the open source project, not the mathematician? It's okay, you don't have to be. If you're interested in any sort of, well, you know what, never mind. After having gone through the thorium talk, forget it. If you're interested in monitoring, look into thorium. So regardless, there's a service, it's called Remon. It needs config files. Naturally, we're responsible. We manage them with Salt. We're also extra responsible. We manage all of our configs in Git. We don't want to have to git clone, modify our configs, git push, go to Remon server, take the config files, copy them in there. Even if we do have everything arranged with Salt, so we just say salt remon.running, and then that's enough. Even if we do that, which we have, that still is another command we need to run. We don't want to do that. This is what I want, and it's what we have, in fact. A user takes that Remon config, pushes it up to GitHub, which then has a webhook that runs that post. Remember that Salt API post? Pushes that over to Salt API, which is then via reactor configured to run our remon states, which include getting the latest config files out of Git, optionally restarting remon if necessary, and Bob's your uncle. All you did was push the config into GitHub, and now the brand new configs are out there in production. No extra work involved. So I'm with Cloudera. We do Hadoop sometimes. Something that we do often is our customer operations engineers, the guys that solve customers' Hadoop problems. They need to recreate Hadoop clusters, and we have that capability. But what we really wanted was to be able to reproduce a Kerberized Hadoop cluster. Does anybody have any experience building a Kerberized Hadoop cluster? I'm so sorry. So Hadoop's hard enough. Kerberos is hard. Kerberized Hadoop is long days, very long days. Okay, so I'll skip through the laundry list and get straight to the visuals. So here's what we decided to come up with. We have our own Active Directory, isolated Active Directory instance, non-production. It is just dedicated to the reproduction of customer issues. We also have this really clever application that I cannot take credit for writing that we call Cluster Deploy. What this is our users will fill out a web form, they'll click a button, and they get a Hadoop cluster. So what we did was we added a little tiny checkbox to the bottom of that form that says also Kerberos. So what happens on the back end when users click that button is the application will hit our Salt API, send another post over there, telling it someone needs an OU created in Active Directory. To avoid getting too far into Windows, suffice it to say, things need to happen in Active Directory so that your Hadoop cluster can connect to it for Kerberos-related services. So what we have then is our hook into Salt API, which contains in the post data is going to be some interesting details about how to implement those things that need to happen in Active Directory, which then run through a templated PowerShell script, God bless PowerShell, which then runs on our Active Directory box, which creates the OUs, creates the user accounts, does some delegations, and we're done. The application is going to send the login details back to the users, and they have what they need out of their Active Directory service. We don't have to maintain login accounts for our users to log into Active Directory. God save us if we had to manage user accounts where our users would log into our Windows server and manually create OUs to make their Kerberized clusters. It would be an absolute nightmare. This capability has saved us an incredible amount of time. So those are some of the use cases with some of the components. I wanted to make sure I didn't go over on here, so these are just a few of the components that we didn't have time for in here. Salt Syndic is your master of masters. I've run Salt masters distributed geographically around the planet. I mean, I've had a master of masters living in one hemisphere, and I've had several submasters living in another hemisphere on the planet. This was a couple of years ago when it wasn't even as good as it is today, and it was impressive. The response time was amazing, and how reliable it was wow. If you need painfully distributed systems, look into Salt Syndic. Returners are, when you run a Salt job, that return data comes back to the master, and you see it on the screen. That's nice. What if you need auditing? What if you need some postmortems? What if you need to do something with the text that's on your screen? Returners solve that problem for you. There's already a lot of stock returners, MySQL, Mongo, your favorite database of choice. And as we said earlier, you can build your own returner if that's not enough. So if you have any auditing needs, or if you need to really dig into the job cache, you've got thousands of minions and the screen just isn't big enough to look at the output. This is the beginning of where you build a capability. If you have a returner that goes into a database, you can build a small UI that sits on top of it, and you can much more easily analyze the success or failure of your jobs. The SDB, the Salt database, is a handy database layer. It's another one of those components where it serves a niche field where once you find a use case for it, you cannot imagine how you could have done without it. And of course the external auth. If you've ever just gone through a getting started with Salt, you may not have realized you're using the stock PAM auth module for Salt. You can use many other authentication systems through the eAuth system on Salt. So if you have a more corporate, more rigid enterprise, you have a capability to have some better access controls so that if your anti-cowboy mechanisms aren't good enough, you can also limit what kind of commands that guy can run, or that team of guys, depending on your circumstances. So all of that to say, Salt is way more than configuration management. Salt's a platform to let you build capabilities that best serve your organization, your needs. And in my personal experience, I've seen and built capabilities with Salt that I don't know how else you would make them, even if you had paid software, and especially with how lightweight and how fast it can be and how customizable. It's, you can do some amazing things with Salt, much beyond just managing a configuration file. And it all lives on top of this message bus. Look more into this. The message bus is the central nervous system to your data center. You can do a lot with the information that's going across there. So this is the end of the main part of the talk, and this is where we can open it up to some Q&A if there's any questions, rebuttals. Yes?
So I have two questions. I guess the first is with beacons. Have you looked at using beacons as like a trigger for alerts that you typically use like Nagios for? So like I've been looking quite a bit at like running like NRP type things with beacons so I can eliminate the managed Nagios in my environment.
In a word, yes. So the answer, the question was, have I looked into using beacons to deliver a capability similar to Nagios? Is that about right? Yes, absolutely. I myself have not done the legwork of doing it, but I have seen it done, and there's absolutely nothing getting in your way from using beacons. And with just a couple days ago, Thorium having been announced, if you're interested in a true monitoring capability with taking action and notifications, Thorium is Reactor on steroids. It suits exactly the need that you're going after.
And then the other question I had was around when you had that Active Directory slide. Is there a reason why you chose to use PowerShell scripts over like some of the Salt LDAP modules that are out there for manipulating LDAP via Salt natively?
So the question, with this Kerberos Hadoop cluster capability, why a PowerShell script instead of the Windows capability of modifying Active Directory objects? I'm embarrassed to say I didn't look into those abilities. Now I want to go back and look to see what we could have done. I wonder how much time that would have saved me. That was a good question. I need to go back and look at that. Yes?
We don't have an active directory.
There is no yet. But you can issue LDAP.
We can authenticate LDAP.
Well, I think you should modify it as well.
So since we're on the topic, so what that it does. All right. So all it does is it makes a couple of OUs, makes an OU, makes a couple service accounts, and then it delegates authority of the OU to one of the service accounts. That was really cagey to do with PowerShell. I'd be really shocked if that capability was native in Salt Windows. I mean, I would love for it to be there, but I understand Windows is very hard to instrument.
Can you send me a copy of your script?
I will, yes. All right. So if we're out of questions, we're not out of questions yet. Let's go back.
Your database. How much do you use that? I mean, is it very capable? I mean, how much data do you think you could put in there?
Which database would you mean?
The SDB.
So the question is, how capable is SDB? I'm, again, embarrassed to say I'm not fully versed on SDB. If anybody else is.
You can really only do git and set.
Okay. Thanks.
There's no file size constraints or anything like that, but given that you can pull out you can only pull out individual values. It's a way to kind of intersperse bits of data within your SLS file or config file or pillar file and keep it external to one of those things. it's kind of a piece of
It's a great key value store though.
All right. Yes.
What was your, you said with engines, once you find a killer use case for it, nothing else to do, what was
So imagine you've got, I'm a huge fan of Salt API. So going from Salt API to like Salt Cloud, that chain of actions is something that really fascinates me. Being able to build like, go with this use case. You've got an in-house API. You want to deliver some sort of a PaaS capability. So you've salted the creation of all of these services and all of these features. Wouldn't it be nice to kind of make that specifically available to some users? Salt Enterprise and other UI tools notwithstanding. You could have a UI that sits on top of your Salt master. Wouldn't even have to be on your master. It just has to be able to hit the Salt API. And it would send the data to the Salt API, which then can drop some information on the message bus. That's where the engine comes into play. When you have an engine, you're not limited to just reactor states and salt states. You have an entire standalone Python process. So you have the full power of Python to do whatever you need to do with that. And that includes instrumenting all of the native Salt APIs, like the cloud client and everything like that. So you, from there, would be able to do whatever is necessary to authenticate to your internal or external cloud provider, create the VMs, and then follow on with bootstrapping them and then adding additional capabilities onto those. That was a good question. Thank you. Yes?
On your API, your enterprise versus the open source, what's going to be the biggest differences between enterprise?
I am totally deferring that one.
I can feel that one.
Okay.
So the open source API, Salt API, it wraps Salt's Python API very transparently. It does what Salt does. You just call functions in Salt. It's pretty single-mindedly purposed to put stuff on Salt's event bus, expose Salt's event bus, and call functions in Salt, the same as you would with the CLI. So anything you can do with the CLI is just kind of natural for the Salt API. The enterprise API is a separate product. It lives above Salt. It does its own thing. Salt integrates with it. Salt pushes data into it. It tries the enterprise UI. But you're not missing out on anything. Salt can do it. You can do it with the CLI. Salt API can do it. The enterprise API is that add-on, right, to do things that Salt can't do. Aggregate data, visualize data, that sort of thing.
Go ahead.
So, I guess I'm reasonably new to Salt. Kind of our team's been using it for about a year, but strictly Linux, and they said, hey Dustin, you're a Windows guy, figure this out for Windows. So a lot of I have like a .NET background, so a lot of the Python and Nessun scripting is a little bit foreign to me. Can you maybe just give me a little bit better explanation of the engine? I get that you can run alongside with the Salt Master, but I mean, I don't understand.
So I'm glad to, but it's not necessary if you want the Windows integration. That being said, we can go down the engine path.
Sorry, what?
So the question is, it sounds like you're asking about a little bit more details on how engines work.
Yeah, how does
In the context of having to also maintain some Windows servers.
Not necessarily.
Okay, so never mind the Windows servers.
They're making me learn everything. As I think Shane said in his thing yesterday, it's easier to teach a Windows guy to learn Linux than teach a Linux guy to want to use Windows.
Sure,
That's
so
how it's working out. So just in general, I'd like to understand what value does the engine bring? I didn't see it.
sure. So it's if you want to write so an engine is a separate Python process that runs alongside your master. It has access to everything that Salt does, which includes the event bus. It includes all the configurations. It can include Pillar. So when you find yourself saying, I really wish I could have the Salt master do some capability, write yourself an engine, have it sit next to the Salt master, and just implement that capability in Python yourself.
Okay, cool. Thank you.
Sure. So I'll be here a little bit after this, but in the meanwhile, thanks everybody for making it out. If you can spare a feedback, I'd appreciate it. Otherwise, thanks again for staying. Congratulations for making it to the end of the conference.